So today, linear inequalities, we're going to graph a line, and you might remember this from Algebra 1. You're going to shade the true side. So if you're taking some notes right now, the first thing you want to do is write down our objective, then 2-5. We're going to graph linear inequalities, but the main thing that today, you always shade the true side. We're going to be looking for that true side. So what we're talking about here is that we're going to have a Cartesian. We're going to have to graph a line, y equals mx plus b. Sometimes it might be dotted because it's only greater than or less than. Sometimes it'll be solid. And then we're going to look for the true side by plugging in, most of the time, 0, because it's easy to calculate. And this might be the true side. And then we'll shade. This should be remind you from Algebra 1, you did this, remember? So the skill is not that hard. Graphing a line, we've been struggling a little bit with that earlier in the year, but you're going to graph a line and then shade. So if you do have some graph paper, it might be helpful. If you don't, again, you can just draw out your axes and label them. Graph your line and shade the true side. Now the dotted line versus the solid line, it's dotted if it's only greater than and less than. It'll be a solid line if it's greater than, equal to, and less than and equal to. Let's get right to it and graph a linear inequality. Here we go. So I'm going to give you a couple steps. I always like, to me, is to write it with an equal sign. So I prefer to do that as step 1. Write it as an equal sign. So step 1 for me. So I'm going to go y equals negative 1/3 x plus 2. The reason I'm doing that is that's going to help me graph. Okay? I don't want to mess with the inequality, especially if it's not in a form that's going to help me graph easily. Okay? And I want to be able to graph it easily. This is already set up in what? Mx plus b, isn't it? So it's really ready to be put down. But sometimes it's not. Sometimes you might have to find the intercepts and do a little bit more work to get it going. But this one's already set up. So what's my intercept? Is positive 2. So we know that point there is x is 0, y at 2. We want to get in the habit of labeling a couple of points, at least 2 on your line. Get in the habit of labeling 2 points. So step 1, we're going to write it with equal sign, and then we're going to graph. I'm going to use my slope now, and it's 1/3. It's negative 1, so down 1 over 3. And now I'm going to label that point as x at 3 and y at 1. So I'm done labeling my points. So step 1, write it with an equal sign. Also part of step 1, you might need to solve to be able to graph, right? If you want to use mx plus b, or what's our other option is the intercepts. Plug in 0 and get your intercepts. So it's either mx plus b or intercepts so you can graph the line. Graph 2 points. Is everybody good? Now I'm going back to step 2. I'm going back to this equation with the inequality right here. And I'm going to check this out right here. What is it? It's just what? Greater than. So now I'm going to make my line dotted. And it's a small detail, but one you don't want to forget. So if it's right on the line, it doesn't count in part of the solution because it's just greater than. So again, step 1, write with an equal, y, so we can graph it. mx plus b or intercepts. Step 2, figure out if it's a dotted or a solid line. So far, so good, everybody. Should you remember this from good old algebra? 1, step 3, test. Find the true side. Okay, we're going to find the true side. How are we going to do that? Well, we have to pick a data from one side of the line or the other, right? Very easy to calculate is that spot, because I can plug zeros into this original equation here. I'm going to plug zeros in. So let's do that right here. 0 greater than, I'm going to get 0 there, 2. All I've done was put 0 in for y and 0 in for x, and I get this guy right here. Now, is that true or false? Is 0 greater than 2? This is false. So that means this side is false. Why is that side false? Because that's where I plug the value in on that side. But as I started out today's lesson, what did we say? Always shade the true side. So which side do we need to shade? The other side. And you can just draw a couple lines that way. Don't go too crazy on shading. Slim shading. Right. So we have an inequality, step 1. Why am I liking step 1 with an equals? Because you might have to solve something, and then you start switching the inequality, and you get yourself all messed up. So just keep it with an equals. This one, we didn't have to do a doggone thing because it was already in mx plus b, right? Step 2, see if it's a dotted, okay? Dotted or solid line, right? Step 3, test. Find out what side. What do we want to use often is, of course, zeros, isn't it? Because it's easier. Now, if the line goes right through the origin, 0, you might have to use 1, 1. That would be my second best number to use, 1, 1. Question?
So, I forget, how do you tell if it's dotted?
If it has just a greater than and less than, it's dotted. If it's greater than or equal to, then it's solid.
Okay, greater than.
Yeah, if you have the equal sign in, it'd be solid. All right, let's try another. This one's kind of a little bit of an anomaly. Is that the right word? I'm going to write it as y equals -1. Step 1. Now what? Got a graph. This is a little different because it's y equals a number, so it's going to be what kind of line? Vertical or horizontal? Y equals -1. Anybody?
Horizontal.
It's going to be horizontal. Thank you. Is it going to be a solid line or a dotted line is the next step. So step 1, step 2, is it dotted or solid? It is a solid. And that solid line is right here. We're on to step 3, looking for that true side. So we'll go back to our inequality. Is 0 in play? Yes, it is. Plug 0 in for y. And now you have to think about that statement. Is 0 less than -1? You can read it the other way too. If it gives you trouble, read it both ways. The other way would be, is -1 greater than 0? This is false, isn't it? So my false side is here. So what side do I always shade? The true side. So we can't just have a y equals line and x equals line, you just plug in a y value or the x value, you get it going there.
So number 2 seems flawed.
Is it dotted or solid? Is it a dotted line or solid? This one was solid. Dotted or solid. Step 1, write it with equal sign. Step 2, dotted or solid. Step 3, find that true side. Along with step 1, of course, you got a graph. So you are graphing the line with step 1. You might have to manipulate it a little bit. Got one more in you? All right. I'm gonna let you go with this one for a second, see how far you get. Excuse me. Is this one set up to graph pretty easily? Yeah, it's already what? It's an mx plus b for you. Okay? I still am gonna write it with an equal sign and graph. So step 1, y equals 3x minus 2. Step 1 is write it with an equal and graph. So graph -2. Slope of positive 3, so up 3, 1, 2, 3 over 1. Label these points. Here is 0, -2, and here is 1, 1. There's something stuck in my throat. Dot or solid? Which one is this? It is a solid line. I'm gonna look for that true side now. Step 3. Plug in zeros. 0 for y, greater than or equal to 0 for x, would leave me 0 there. And then that's our statement. You have to think, is that statement true or false? Because we plugged in zeros from this side. So we're figuring out if this upside here, where the 0, 0 origin is that true or false? Is 0 greater than -2? Yeah, this is true. So that means this side's true, because I test valued on this side. Lemon squeezy? Everybody okay? Yes, please.
So in the last one, you were saying it was horizontal or vertical.
Mm-hmm.
How can you tell?
Well, that's a y equals line and just x equals, there was just no other thing with it. Good question. Okay. One more, this is last one. Use your intercepts and see if you can graph this one. So I'm gonna go step 1, 3x plus 4y equals 12. But this one is not in mx plus b, is it? It's not y equals mx plus b for us already. So your intercepts can be had pretty easily here. Put in 0 for x, get your y, put in 0 for y. Did I say that back? Find your intercepts. If I put in 0 for x, I think my y is 3, is that correct? Anybody else get that? I put in 0 for y, I think I'm going to get 4 here. Now, be careful graphing. Some of you made this mistake on the quiz over this section. X is 0, y is 3. X is 0, y is 3 is right here. X at 4, y at 0 is here. Step 2. Dot. Solid. What is this one? Solid. Step 3, search for that true side, but I got zeros here. Go back, you're going back to this one now and plugging in zeros. Going back to the inequality, so put zeros in for x and y, I'm gonna get 0 on this side. And there's my statement. It's a statement. You have to look at that statement and say, is it true or is it false? You can read it both ways. Is 0 less than 12? Or you can read it what? Is 12 greater than 0? Sometimes it's better for me to see the greater than myself. You might be able to do it both ways. I like seeing, I know 12 is greater than 0. So I use this side for my test, and this is the true side. And of course, we always shade the true side. So this one was a little different. I had to get the intercepts. Remember, how are we gonna graph lines? Either y equals mx plus b or the intercepts, okay? How does everybody feel? Okay? That's fantastic. So you have a couple of problems, 14 through 18. 14 through 18.